So here is the question for the year of the 2025, December 2025. So if you see the pattern, then there are the 20 objective questions. Out of 20 objective questions, each unit will contain the 4 questions. So here is from the unit 2 and 3 and something 4. So totally there are 20 objective questions. Apart from the objective questions, there will be the 5 subjective questions, short answer questions, which will be, that there will be the 2 questions from each unit, from unit 1, unit 2, unit 3, unit 4 and onwards. And out of each unit will contain the 2 questions. Out of 2 you have to solve only 1 question. Lastly, section C will contain the 2 questions, and out of 2 you have to solve only 1 questions. So these are the patterns. Okay, so next to the patterns, we are going to talk the very the important questions which has been asked in previous year questions. So I'm going to focus only on one questions which is common in past 2 or 4 years, like that, so that you may focus on only one question. So my objective is to find out the one or two objective questions, the one or two common questions which has been asked from each unit. So we will cover only 5 questions from each unit. Okay, so let's talk about the first unit. So if you'll see the from first unit, in this question it has asked about electric field intensity. Another question here, it has been asked the calculation of the electric field intensity. In another set, questions has been asked to find out the electric field intensity. In another set also it has been asked the express the the mathematical representation of the electric field intensity. So mostly questions are related to the electric field intensity, either Gauss law or either numerical or either Coulomb's law based, right? So questions is mostly focused on electric field intensity. So in this session we are going to cover one numerical questions. So here we'll talk about these questions. For more questions, you may refer to my another sessions that we have already discussed in our previous sessions. So let's talk about it. So what is this question? Question is that point charges having, that is 1 millicoulomb and minus 2 millicoulombs are located at this point and this point, right, respectively. So 2 point charges are located at 2 different points. Now calculate the electric force on a 10 nanocoulomb which is placed at this point, and the electric field intensity at the point, right? So first we will find out the force and then intensity. So how we'll solve? So according to the Coulomb's law, force can be calculated as F is equal to K Q1 Q2 by R square. K is equal to 1 by 4 pi epsilon. Since here the force is due to the multiple charges, so here it will be the summation, right? Why? Because we have to add the forces due to the different charge particles. So that is why we are adding, the using the summations. You may also write the for F1 plus F2 plus F3, right, like that, and then put the values. Like first we are calculating this point to this point to this. So find out the distance and then the charges, that is q1 q2, and replace the values. So here we have, that this is the way to find out the distance, that is r1 minus r2 and whole square plus the y1 minus y2 and z1 minus z2. So this manner you can calculate the distance, and charges is already given, like q1 is 1 millicoulomb, q2 is minus 2 millicoulomb, q3 is already given, right? So in this manner you can find out. So once we'll get the final value of the force, then you can easily find out the intensity, that is f E is equal to f by q. So this is the final answer for your electric field intensity, right? Now let's talk one questions from unit second. So unit second is mostly focused on the magnetic field. How will you find? So question is magnetic field intensity you have to find due to the long straight conducting wire, current carrying inductive wire, using the Ampere's law, right? And sometimes question is about what is the basic explanation of the Biot-Savart's law. So this is also related to the magnetic field only. Third one is magnetic field intensity at various regions. So in the infinite long coaxial cable, and another one is the Maxwell equation for time varying in the point in the integral. So mostly questions are related to the magnetic field. So let's see some concept related to the magnetic field. Biot-Savart's law we have already covered, so you can go through this. Major thing is that you should remember the field, that is magnetic field intensity in any current carrying wire, is directly proportional to amount of the current in the particular element, that is ideal, and the angle in between the point to the the your wire, that is sine alpha divided by the distance square. That's all. Okay, so how can we find out the electric field magnetic field intensity due to the infinite line charge? So here is the current carrying wire. Suppose A and B. This is your finite. For the time being, we are considering finite, and then we will extend it to the infinite. Current is carrying, that is I. You have to find out the magnetic field intensity at this P. So how will you find? So first, the Biot-Savart's law, that is ideal cross R divided by 4 pi R cube. So first we'll find out the ideal, then R, and then the R cube, and then put the values. So dl cross R, how will you find? So this is the suppose a small element dl and cross R. So find out in cylindrical format. This will be rho dz a phi, and then put the values of dl cross R, and then get the values here, right? So R is equal to, here this is your capital R, so R will be the z square plus rho square root. So put the values and integrate here. In order to integrate it, the simplified your integration, you can put the z values like rho cot alpha, so dz will be automatically this one, and put the values by replacing the z and the dz, and you get this values. Finally, your value of your magnetic field intensity is I divided by 4 pi rho cos alpha 2 minus cos alpha 1. This is for finite. Now, for infinite, alpha 1 should be 180 and alpha 2 should be the 0. Why? Because alpha 2, it's like if your point P is very near to here, then definitely this angle will be the 0 and 180. So finally, if we'll put the alpha, these values, alpha 2, alpha 1, you will get the H is equal to I by twice by rho A5. So this is the final value for magnetic field intensity. Similarly, these can be found using the Ampere's law. So Ampere's law is nothing. This is your H dot dl integration is equal to I enclosed. That is the linear integral of H, that is magnetic field intensity in a particular length dl, is it will be equal to the current enclosed in that. So by using this Ampere's law, you can find the current magnetic field intensity. So H dot dl is equal to I enclosed. So first find I enclosed here. So I enclosed is how much I, which is enclosed in this wire, and what is the H dot dl? So dl will be nothing, twice by R. So suppose this is your R or rho, then twice by rho. So H is twice by rho is equal to I enclosed. So H will be I this. So in this manner also you can calculate. Now let's take one question from unit third. So here the unit third is mostly focused on the rectangular waveguide. So here you can see transverse electric wave in the rectangular waveguide. So wave propagation in the lossy, or the derive the field components of transverse mode, TM mode, and derive the field components for transverse magnetic mode. So TM mode and TE mode, these are the important topics, right? So all process steps are same for TM and TE. So let's consider the transverse magnetic mode, that is TM. So here are the boundary conditions for the rectangular waveguide, since we are deriving it for the rectangular waveguide. So if you'll remember, this is a very important equations, right? So if you'll remember, this is your h square is equal to kx square plus ky square. Kx is nothing, m pi by a, and ky is equal to m pi by b. So a and b are nothing, the side of the rectangular. Like suppose this is a rectangular, then a and b is the side. So length of your height and width, and then you can get the propagation constant, these values, and when will it be zero? So exactly kx, the your kx will be m pi, and definitely m is equal to 1 2 like that. because its solution your electric field in the propagation direction, it will be, this will be the solution, right? So you can remember the two equations, this one and this one, then it will be very easy to find out the transverse magnetic components, right? Rest is nothing, find out the kx value, ky value, and put it here. And once you will put, then you can get the value of the cutoff your frequency. So how much frequency will it propagate? So here the kx square is, k square is equal to these values here, and omega square mu and minus of m pi y square plus n pi square. Yeah, this is actually the propagation constant, right? So for cutoff, like definitely this one should be 0. So here omega c will be these values. So and further, if the your propagation constant is higher, then in that case your gamma is equal to alpha, and your k square, this value will be the lesser than these values. And for this is called even scan, means light will propagate outside, wave will propagate outside to the rectangular waveguide. And for propagation, if your wave is propagating inside, then definitely it should always be greater than. So this is the best condition actually, your k square, that is this value always greater than this. However, in order to calculate the cutoff frequency, this is the most important equation, right? So this is the most important equation that you should remember. Sometimes numerical questions may also ask to find out the cutoff frequencies, right? And how many modes will propagate, so you can use this formula only to find out. So this is the most important formula in the unit third, right? I have also solved one the numerical problems. You may go through that in our previous discussions, right? So here is the cutoff wavelengths only, cutoff frequency only. And similarly, you can also find out the wavelength and corresponding to the eta, that is the intrinsic impedance. Let's take one question from unit 4. So here you can see the derivation of the voltage and current equation in the transmission line. Here distortionless line, then consider a two conductor transmission line, draw the equivalent circuit. So equivalent circuit for the transmission line is the common question, so we'll see it. So here is actually, these are the different transmission lines. So we are going to solve this parallel, that is middle one, two conductor parallel one. So equivalent to this, you can draw this type of circuit. So here is nothing, R and inductor, that is resistor inductor, and the capacitor and conductance. Conductance is nothing, 1 by resistance only. Equivalent to this circuit, you can draw it like this. So your resistor, inductor, and the conductance and the capacitor. So this is the part of your transmission line equivalent, right? Now how the current will flow? So use the KVL and KCL and write down the how the voltage will pass. So here just how voltage you are applying. So find out the using the KVL and KCL the voltage and current, and they get the the propagation constant value. So this is the idea to solve it. So here the according to KVL only, this one is equations that you can get it, and according to KCL you will get the current equations. Now you can replace it and solve the values for the V and I, and for the if you will solve, then you will get the values this one. So this is the most important equation, right? So here is your del square V by del Z square R plus j omega L and into j plus j omega C. If you wanted to know the each of the steps how to solve these things, then we have already discussed in our previous sessions. You may go through that. Right now I'm going very quickly to point out the only very much important point, right? So this is the much more important equation. So never forget to write this one. This is the most important. You can remember, right? So with the help of this only, you can write the propagation constant. That is gamma is equal to, see here, this one value only copy and paste. So R plus j omega L into G plus j omega C. And this is the value of gamma. And with the help of this one only, you can identify the two different conditions. Also, you can find out a Z naught, that is the impedance for this transmission. And for your transmission line, when it will be the lossless, so in that condition R equal to 0 plus G is equal to 0. In that condition, again you have to find out the alpha and beta. So how will you find out alpha and beta? So already you have calculated the gamma, that is your r plus j omega n into g plus j omega c. That is the most important one. So here also your propagation constant gamma is equal to what? Alpha plus j beta. So equate both and you will get the values of alpha and beta and also z naught. So again we have already discussed in brief in the previous session. For distortionless, R by L is equal to G by C. This is the important condition, and put the same values and get the values of alpha and beta. Right, here is the summary. So these are the three different conditions we have discussed. Okay, so we'll consider one more question, the important questions from last unit, that is fifth unit. Fifth unit is basically referred for the the solving, how to solve the questions on the transmission line. So we are going to use the Smith chart to solve the transmission line from unit fifth. So here you can see the common questions. So explain impedance, impedance matching. So there are the stub matching and the quarter wave transform matching. Those things I am not considering here. We'll see the Smith charts. So if you know the Smith chart 100%, you can solve and you can get the marks for these type of questions. So here your transmission line is given like 30 meter, and then operating with the impedance is this, wavelength is frequency is this, and Z load is given, speed is given, and you have to calculate the tau s and Z in. Right. Similarly, if you see here, the question is given a find out the standing wave ratio, that is tau Z naught. So like that. So by using a Smith chart, you can solve these common questions. So let's take some one question. In this question, your 30-meter long lossless line is given, Z naught is given, and frequency is given, and ZL is also given, speed is given. So we have to calculate the tau and S and input impedance. So how we'll find? So very easy. First, find out, the first you have to solve using the Smith chart only. So how will you solve? So in order to solve the, the questions related to the transmission line using the ZL, first find out the normalized ZL. So here is your ZL. This is, that is 60 plus J 40J. But in order to make it normalized, divide by 50J, that is ZO. Then you will get the normalized ZL. So value is 1.2 plus J 0.8. Now locate this point on the Smith chart. So here is your Smith chart. Basic about the Smith chart is that there are the two different circles. So like these type of circles are there. This is called real part circles, and the semicircles like these, and these are the semicircles are representing the complex numbers, right? Complex part. So now locate this real part and imaginary part. So real part is here like 1.2 here, and then imaginary part is 0.8. Was after finding the the Z naught, ZL, whatever the real plus imaginary, locate this point, extend it from this point. This point means what? This is your R is equal to 1 and 0. So you can treat it as a center. What is that center? R is equal to 1 and X is equal to 0. So this is the center. Extend it, and whatever the values you are getting, this one, this is definitely ZL. Now in order to find the tau, extend it and take the ratio, measure these values like the 3.2 centimeter, and from origin to this cutting point is 9.1. Take the ratio, you will get the tau. After getting tau value, you can also measure this angle from this line, x is equal to 0 line. You will get the final value, which will also give you the what is called the complex part. As that is, if you wanted to find out the standing wave ratio, simply draw the one circle like by considering 0 and ZL. Point P, like draw the circle, and wherever your circle will cut on the x is equal to 0 line, so this value will be the value of S, right? So value is 2.1. Now lastly, input impedance at some different points. So you know the input impedance at point P, but you have to calculate the input impedance at this point. So you have to move it. So in order to first find out the L. So you can get the L is equal to how much you are going to move by 240 degree. So from here to 240 degree, just move it, and wherever it will go, just draw the line, and then this value will be the normalized value here. So normalized is from here to this one. So here this is a 60 56 now, 56, then this is your 180, and so 4 degree more. So this will be the 240, and then after getting the value of z normalized, multiply by the z naught, that is 50, and finally this is the input impedance at this point. So that's all, and these are the previous year questions paper, and these are the discussions. In the next sessions we'll also see the some very interesting the sessions related to the gate questions. So we'll see the at least 10-year different questions related to the gate which has been asked from this course, that is electromagnetic theory. So please be stay here. Thank you for thank you to joining the sessions. If you have any doubts, please drop your